There was a period in the early universe when almost every single galaxy in the night sky stopped making new stars. It is known as the Epoch of galaxy quenching, and it was a pretty weird time in cosmic history. We don't know exactly why this happened, but we think it might have something to do with supermassive black holes heating up all the gas around them, which would make it really hard for new stars to form. This event also likely explains why so many of the galaxies we see today are red and dead. The reason they are not making new stars anymore is because they were all once normal spiral galaxies like the Milky Way that went through some sort of violent transformation long ago. And we think that transformation might have been triggered by a supermassive black hole. So understanding what caused this sudden shutdown of star formation could help us understand how these enormous black holes grow and evolve. But first, let's talk about what this period of cosmic history actually was and why it's so weird. We call it the Epoch of galaxy quenching because it marks a period when galaxies went from actively forming stars at high rates to shutting off star formation basically overnight. We think it happened between 9 and 11 billion years ago when the universe was still relatively young. Back then, the average galaxy was way smaller than the galaxies we see today, and they had a lot more gas compared to the amount of dust and stars they had. This gas was kind of spread out around the galaxy, and it's important to remember that most of this gas wasn't just floating around freely. It was gravitationally bound to the galaxy, just like our moon is gravitationally bound to Earth. So even though we call it gas, technically it should probably be called a cloud or a disk of gas. And this gas was cold enough to form stars, and giant clouds of cold gas are where stars form in modern galaxies. The process goes like this. Gravity pulls the gas together into clumps, and the clumps collide with each other and build up until they collapse under their own gravity. As they collapse, the clumps heat up until they're hot enough to start nuclear fusion, and that's how stars are born. So back in the early universe, galaxies had lots of cold gas and lots of small stars, which meant that most of them were actively forming stars at pretty decent rates. But during the Epoch of galaxy quenching, those galaxies went from being filled with young stars to having none at all. And to get an idea of just how big of a deal this is, consider that the youngest stars in the universe are only a couple billion years old. And there are already galaxies in the universe that haven't made a single new star in over 13 billion years. So the ability to form new stars just disappeared sometime after the Big Bang. And if you look at the galaxies that are no longer forming stars, they tend to be found in groups and clusters. And if you look at the galaxies that are still actively forming stars, they tend to be isolated. That made scientists wonder, did the group environment somehow turn off the ability of galaxies to make stars? If so, what was it about the group environment? One thing that is different about groups of galaxies is that they tend to have more massive central galaxies, and they tend to have more massive black holes at their centers. So one of the leading hypotheses to explain galaxy quenching is that these massive black holes somehow heated up the gas in nearby galaxies, which would prevent them from forming stars. That hypothesis came about because astronomers noticed that many of these so-called red and dead galaxies have huge clouds of hot gas surrounding them. They can tell it's gas because it emits light with a specific pattern that corresponds to hot, ionized gas. But the gas doesn't seem to be doing anything. It's not forming stars, and it's not colliding with anything else. It's just kind of floating around there. So one idea to explain this is that the hot gas is a remnant of the cold gas that used to be in the galaxy. It got heated up long ago and expanded outwards until it was no longer dense enough to form stars. But the question is, what heated it up in the first place? The main suspect is the supermassive black hole at the center of the galaxy. These black holes are millions or even billions times heavier than our sun, and they are surrounded by glowing clouds of gas that are heated up to tens of thousands of degrees. This hot gas is called the circumnuclear medium. And since it's much less dense than the rest of the galactic gas, it's much easier for the wind from the black hole to blow this hot gas far beyond the galaxy. In fact, computer simulations show that the winds from these active black holes can easily blow the hot gas hundreds of thousands of light years away from the galaxy. And here's the important part. The expanding shell of hot gas pushes the cold gas out of the way, but it doesn't actually mix with it. That's because the cold gas is much denser, so it's kind of like trying to push a beach ball underwater. The water can't push the ball down, even though the water is more massive. In other words, the hot gas from the black hole creates a bubble that expands outward and prevents new stars from forming in the surrounding galaxies. And based on how fast the bubble expands, scientists estimate that it would take less than 100 million years to heat up all the gas in a galaxy and kill its star formation. And that timeline makes sense because the Epoch of galaxy quenching happened sometime before 9 billion years ago. So the black hole winds could have heated up the gas in all the galaxies around them while they were still in the process of forming stars. But once the gas was heated up, star formation would have turned off. That explains why so many elliptical galaxies have huge bubbles of hot gas around them. But it doesn't quite explain why so many of these galaxies are found in groups. One idea is that the sheer mass of the central galaxy in a group is enough to turn off star formation in its neighbors. According to simulations, if the central galaxy has a sufficiently large black hole, it can basically starve the neighboring galaxies of gas. Because the black hole's gravitational pull is so strong, it pulls all the gas out of the neighboring galaxies and into the central galaxy. And when the gas gets pulled into the center of the massive galaxy, it just adds to the existing hot bubble of gas. But that doesn't explain why quenching seems to happen so suddenly. Why don't galaxies just slowly stop forming stars instead of turning it off like a light switch? Well, one idea is that the amount of gas in a galaxy needs to drop below some threshold in order for quenching to happen. Once it drops below that threshold, the remaining gas can't produce enough stars to sustain the process that makes new stars. It's kind of like if you have fewer than 3 friends. You're unlikely to start a club because there aren't enough people to go around. Or if you have fewer than 12 eggs, it's pretty hard to make an omelet. So maybe it's kind of like that for galaxies. If they have less than some critical amount of gas, they just can't make enough stars to keep the process going. It's still not clear why exactly this happens, but one idea is that if a galaxy loses too much gas, there won't be enough to cool down the central black hole. And if the central black hole isn't cooled down, then it will continue heating up the surrounding gas and blowing it away until there's not enough gas left to form stars. All this speculation about what caused the Epoch of galaxy quenching goes to show how important it is to study these ancient galaxies. By tracing the history of star formation throughout the universe, scientists can piece together how everything evolved over billions of years. So, if you want to learn more about how the Epoch of galaxy quenching happened, you can check out another video we made on the James Webb Space Telescope. Thanks for watching this episode, which was brought to you by our amazing patrons. If you would like to help us make videos about awesome space stuff, you can check out our support page.